We're going to be talking about writing and graphing compound inequalities. To begin, let's go over the definition. A compound inequality is an inequality formed by joining two inequalities, so two, with the words and or the word or. Let's go over what we mean by and or. And inequalities means that we need to meet both requirements. Or means that we need to meet at least one requirement. And we can meet either of them. For example, if I am talking about writing a ride at Lagoon, if a ride states that you need to be at least 13 and 5 feet tall in order to ride a ride, that means you have to be both at least 13 and older, and you need to be at least 5 feet tall. So you have to meet both of those requirements if they use the word and. Now, if instead they say you need to be either 13 or you need to be 5 feet tall, that means if I'm 11 but I'm 5 feet tall, I can ride the ride. Or vice versa. If I'm 4'8" but I'm 13, I get to ride the ride. So and, again, both requirements, or I fit at least one. Let's talk about and inequalities. If I'm looking at the inequality, x is greater than 2 and x is less than or equal to 5, well, let's start by looking at them separately. X is greater than 2. Well, here's 2 on my number line. Here's 3. Here's 1. I'm looking at all of the numbers that start at 2 and are greater, but don't include 2. If I'm looking at x is less than or equal to 5, here's 5. 5 is a solution, and anything less than or equal to. And I'm looking at the numbers 4, 3, and down. Now those are those two separately, but if I am looking at the inequality as a compound inequality, and I notice that it uses the word and, that means in order to be a solution, it needs to meet both requirements. I need to find a number that is greater than 2 and a number that is less than or equal to 5. So for example, 3 would be one of those numbers because 3 is greater than 2 and it's less than or equal to 5. But we need to make a graph that represents all the possible different solutions. So I'm going to write my numbers on my number line. 2 on the left because it's smaller, 5 on the right because it's larger, and here's some numbers in between, 3 and 4. 2 is not a solution to both because we can't equal 2. 5 is a solution to both. Okay, and anything in between. That includes 2.1 is a solution because it's greater than 2 and less than 5. So that is an and inequality. An or inequality, so if I look at them separately, y is less than or equal to negative 2. Negative 2 is a solution, and anything less. If I look at the inequality, y is greater than 1. 1 is not a solution, and anything greater is also a solution. So that means I have numbers negative 3, negative 4, all solutions to the top one. 2, 3 are all solutions to the second inequality. Now if I'm looking at the word or, that means I'm not looking for them to both, I don't have to meet both rules. If I put them both on my number line, negative 2 and 1, okay, there's negative 1 and there's 0, I notice here's 1 greater than 1 and here is less than or equal to 2. I see that there is no number that they meets both requirements, but that's okay. I only need to meet one or the other. So for example, 2 is a solution because it is on this part of the arrow, and negative 10 would be a solution because it meets in that part of the arrow, but 0 would not be a solution. All right, and or inequalities. If I'm looking at a written statement, let's go ahead and practice. I am thinking of a number that is greater than -8 and less than or equal to 4. I'm going to first decide if it's an and or inequality. And I notice right here that it says an and. I'm going to jump graphing for just 1 second and I'm going to write. Now, in order to be a written inequality, it needs to include this word. It needs to specify whether we're talking about and or. So I'm going to start by writing an and. And I could look at most of the rest of these. I'm thinking of a number that is at most 0 or at least 3 or, and I need to use the word or in my inequality. I need to have those written down. So let's go back to the first example, and it says a number that is greater than -8 and less than or equal to 4. Well, it doesn't matter what variable we use to represent my number, but I just need to be consistent. So x is greater than -8, and I'm going to use the same variable again. X is less than or equal to 4. Now, if I put this on my number line, let's go ahead, -8 and all the way up to 4. I want numbers that are greater than -8, so on this side of -8, and less than 4 on this side of 4. It can equal 4, and it can't equal -8, so I'm going to put an open circle. And if I'm looking for numbers in this region right here, to indicate that, I'm going to connect those two lines, and that represents all of my possible solutions. Now, one last thing about and inequalities. Mathematicians like to use a shorthand to write and inequalities, and this is the way I would like you to write all and inequalities in the future. Instead of using x twice and you writing two different inequalities, and inequalities can be written as one. And here's how I do it. I take the numbers on my number line, and so -8 and 4, and I'm going to write an x in the center of them. Now notice that this inequality right here says x is greater than -8. Well, I'm going to duplicate that right here on this portion of my inequality. Now if you write it this way, this way, it matches that one up here, but it doesn't match the meaning. I need x to be greater. So x is greater than -8. Now, in reverse, on the second part, I have the second inequality. I'm going to double use that x, and I'm going to write that inequality in this space right here. So x is less than or equal to 4, and I don't need to reverse my inequality because x is remaining on the same side. So this right here is going to be my final answer. All right, let's look at example number 2. I'm thinking of a number that is at most 0. At most. Okay, if 0 is the top limit, then I want numbers, and we're going to pick a different variable because we can. 0 is my top limit, and it can equal 0. Or at least 2. I'm going to use the same variable again, and at least means greater than or equal to 2. Now, some of you might be tempted to write a inequality that's combined like up here on the and, but you cannot. Okay, don't. Okay, don't write them combined. This is going to be my final answer. If I write them on my graph, here's 0, here's 2, notice for my and inequalities that I have two endpoints and it's connected in the middle, and or is going in opposite directions. In most cases, this is true. All right, take a second and pause and try this next one on your own. All right, let's go ahead and try this. I'm thinking of a number that is more than 0 and less than 10. So we have an and inequality, and I'm going to write an and to begin with. If you're ready to jump to writing just one inequality, like on this first example, you are welcome to, but you don't have to. I'm going to take this intermediate step. So x is more than 0 and x is less than 10. Now I'm going to write my middle step, my inequality. So now I'm going to write my new inequality. 0, 10, okay, and x in the middle. X is greater than 0 and x is less than 10. And if I graph that, 0, 10, open circle, and they are combined. I am thinking of a number fewer than -6 or no less than -3. And this is going to be the last example, and you're welcome to try the last two on your own if you'd like extra practice. I'm thinking of a number that is fewer than -6 or no less. So y is fewer than -6 or, so it's an or inequality, and I'm going to write the word or, no less than 6. So y, if it's no less than -3, that means it's got to be greater than or equal to -3. Now there is no way for me to write the shorthand version of this. Okay, so I am going to leave this as my answer, and I'm going to graph it. So y is less than -6, and y, and greater than or equal to -3. All right. Today's temperature will be above 32, but not as high as 40. Notice this inequality does not use and it doesn't use or. So you need to use your context clues to decide which one it is. It's going to be above 32, but not as high as 40. Well, think of what numbers those could be. That could be 33, 34, 35, 36, 37, 38, 39, and any of the decimals in between. So notice we're between two numbers. If we're between two numbers, that's just like an and inequality between some endpoints. So I'm going to write an and inequality. Now you can write them separately to begin with. X is greater than 32 and x is less than 40. Or you can jump straight to my answer, which is going to be written as one inequality. 32, 40, x in the middle. Remember, smaller number on the left, bigger number on the right, and flip your inequality as needed. So this would be my final answer. Discounted movies are available to children under 12 and 65 years and older. So my discount is available to less than or equal to 12, and they use the word or, so I'm going to write the word or. Discounts are available to those that are greater than or equal to 65.